Page 5 and 6 of descriptive statistics. First, there's a leftover problem from the last set. The mean and median of a set of 9 measurements are both 12. Some of the measurements are 7, 9, 11, blah, blah, blah. Find the other 2 measurements. Okay, so let's see if we can use the median to figure out one of the missing ones. Well, it says that the median is 12. And they've kindly arranged everything in order for us. We need to put 2 numbers in here to make it so that the median is 12. Well, let's see, 12 is going to sit here because that would be in order, right? And it's going to be in the middle. So let's see, 1, 2, 3, 4 on the right. 1, 2, 3 on the left. Okay, so we do know that 12 is going to be here, and we know that the other one is going to be somewhere around, between here and here. Okay, so somewhere around here there's going to be the second number, which we don't know exactly what it is. So we do now know that one of the numbers is 12. And then the last number is unknown. But as we know the average, all we need to do is we need to add up the numbers except for the box numbers. We have box plus 7 plus 9 plus blah, blah, blah. Make sure we put the 12 in there that we just included. And if we add all those up and we divide by the number of numbers, which is going to be 9, then we're going to get the average of 12. Okay, so now we're just going to do some algebra, and we're going to add up all the yellow numbers here, and then we're going to multiply the 9 times the 12, and then we're going to do some algebra. So let's add up the numbers. 7 plus 9, blah, 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 plus 19. 102. So the yellow numbers are 102. So actually we have something plus 102 divided by 9 is equal to 12. Let's multiply both sides by 9. We're going to get x plus 102 equals 108. And then we subtract 102 from both sides, and now we know that x is equal to 6. Okay? So one of the numbers is going to be 12, and the other number is going to be 6. All right, 20b2, page 512 reading. In a frequency table, how does a cumulative frequency column help you find the median? A cumulative frequency column is an additional column that you have here, which is just kind of a running total of each of the numbers to the left. So the first number is always the same. You say, why is there a cumulative frequency column? It's just got the same number as the frequency column. Oh, because they're going to add these up cumulatively. So the next one's going to be 16, the next one's going to be 27, the next one's going to be 30, right? So that's a cumulative frequency column. So how does this column help you find the median? Well, think about what the median is. The median is the middle number. And the first thing you do when you figure out what the middle number is, you need to find out how many elements there are total, okay? And so we already know the number of elements total, and then we need to say, okay, but where is the middle number, which in this case is between the 15th and the 16th number? Where is the 15th and the 16th number? Well, this doesn't really tell you that, right? But this does. Because when you look at this, you can say, oh, here's the 4th number, here's the 16th number, and you're all like, oh, there it is. The 15th and 16th number is inside this row. Okay, so the median is going to be 1. All right? Okay, so that's how it helps. So we're going to write here that if you have the cumulative frequency column, you can just check to see which row includes the middle index to see which row is the median data. Okay? For example, if there are 100 data points, then look in the cumulative frequency column for the number 50. Okay? Something like that. Alright, so moving along, the table alongside shows the result when 3 coins were tossed simultaneously 30 times. You got this many times you got 0 heads, this many times you got 1 head, this time many got 2, this time many times you got 3. Calculate the mode. Okay, the way you do the mode is you find the most frequent row, which would be this one. Now what do you put? Do you put 1 or do you put 12? You put the data column, which is 1. So we're going to say the mode is 1. What about the median? The median we just figured out is, the median we figured out is here. It's also going to be 1. And what is the mean? Okay, the mean, we need to use the calculator to do that. Basically what the calculator is going to do is it's going to take 4 zeros, 12 ones, 11 twos, and 3 threes and add them all together, get the total, divide by 30. Okay, and the way it does that is with stat edit. So stat edit, and then except now when we do stat edit, remember that I'm clearing here. I can clear rows or clear columns by going up to the table name or the list name and pressing clear. Make sure you don't press delete because that deletes the column. I'm going to put in the data, which is 0, 1, 2, 3. And then I'm going to put in the frequencies, which is 4. And I'm not putting the cumulative frequencies, I'm putting the regular frequencies. 3. Okay, so now I'm going to do stat, calc, 1var stats. Make sure I put list 1 for the first list and list 2 for the second list because that's where I put them. And then do calculate. And the mean is 1.43. Okay? We can check our median also because the median is also here. There it is, it's 1. Okay? Alright. A company claims that their match boxes contain on average 50 matches per box. On during the survey, the Consumer Protection Society recorded the following results. Okay? Calculate the mode, median, and mean. Alright, so the mode would be the most frequent value. So the most frequent one is this 11 here, so that the data would be 49. And the median, we need the 15th one. We can do that by putting a cumulative frequency row here. And so now we have 5, 9, 20. I'm just adding up these numbers here. 26, 29, and 30. Okay, so where there's 30 pieces of data. So where is the 15th and 16th ones? It would be in this class here. So it would be 49 would be the median. And finally, the mean. The mean, we're going to use the calculator. But remember, the way you would do this by hand, and you know, it's a good idea on the IB exam to set this up to show people you know what you're doing. You say, oh, I'm going to have 47 times 5 plus 48 times 4 plus 49 times 11 plus blah, blah, blah plus 52 times 1. Divide them all up, divide by 30. That is how you get X bar. So I'm just going to fill in these two columns here, and we'll be back. Okay, I filled in L1 and L2 with the data here, not the cumulative frequency, the regular frequency. And then I'm going to do stat calc 1var stats. I don't need to change L1 and L2. That was the same as last time. The mean is 49.03. Just put put 49.0. I just need 3 significant figures. Do the results of this survey, I can also check to make sure that the median is correct. Median is 49, yes. Do the results of this survey support the company's claim? The company says on average 50 matches per box, and this says 49. So it says no, 49 instead of 50. In a court for false advertising, the company won their case against the Consumer Protection Society. Suggest how they did this. Well, you know, when they figured out that the average here was 49.03, they only checked 30 boxes of matches. How many boxes of matches does this company produce? You know, maybe millions. So, is that a big enough sample, 30 out of a million, to get an accurate count? Probably not. So I would say that maybe they said that company complained that the study was done with a very small sample size, so the error was large. So they might actually have 50 and, you know, the study wouldn't have known. Okay, number 5. The frequency column graph gives the value of donations for the Heart Foundation collected in a particular street. Construct a frequency table from the graph. So we're kind of going backwards from here. Normally you already have the table of data and then you make the frequency graph. In this case, we're doing the backwards. So remember, we got data and we got frequency. And so the frequency is going to be here and the data is going to be here. It's going to be dollars, it says. Dollars. Or you could put donations, maybe. Donations here. Okay. So you got 1, 2, 3, 4, 5. We got 7, and I'm just reading these off. 7. This would be 9. Next one's going to be 2. Next one's going to be 4. Last one's going to be 8. Okay. So there's our frequency table. Determine the total number of donations. Okay, so we could just add up the frequencies here. That would be 7 plus 9, which is 16, plus 2 is 18, plus 4, 22, plus 8, 30. Wow, they really like the number 30 in this sheet. So 30. Find the mean. Okay, so we're going to take the total 30. Okay, so I put in this table right here, and then I'm going to do stat calc. 1 bar stats, L1, L2 calculate, and it's going to give me an average of 2.9. So the mean is 2.9. The median, like which I could do using cumulative frequency, I see is 2. And the mode, easily I can see from the table that it's 2 also, the most frequent. Which of the measures of central tendency can be found easily using the graph only? The mode. Right, the mode, and if I didn't tell you this before, mode is introduced to you in like 1st or 2nd grade because you can find it so easily in the table. And the frequency graph, it's the most natural one to learn when you can't do addition, multiplication, division. Okay, so 8. The table alongside compares the mass at birth of some guinea pigs with their mass when they were 2 weeks old. What was the mean birth mass? The mean birth mass. And what was the mean mass after 2 weeks? Okay, so they want to know the mean of this. They want to know the mean of this. What was the mean increase over the 2 weeks? Okay, so we're going to do stat, edit, and we're going to put in this data in here. Okay, we're going to put this data, and we're going to put this data, and then we're going to end up kind of doing it separately. But first we're going to put in the... Okay, so what I did was I put the first column here in L1, I put the second column here in L2, and then in L3 they asked for what's the mean increase over the 2 weeks. So what I'm going to do is I go up to L3 and I'm going to say, hey, L3 is equal to L2 minus second L1. So I'm putting a formula in for L3, and I'm going to make L3 by subtracting 210 minus 75, 200 minus 70, etc. Just like Excel. Okay? So now I have these three columns. I'm going to figure out the average for each one. I think the only way to do that is to do stat calc 1 bar stats. Okay, so let's do that. So the first column is 71.1. The second column is going to be, oh, you know, when I did the first column, look, I made a mistake, and this is a very common mistake. When I do 1 bar stats, the second column is not L2. The second column is blank because I'm not doing a frequency graph. This is not a frequency graph. It's just a list. So let me do that again. That was wrong. It's a good thing I did that so you could learn about that kind of mistake, right? So the first one is going to be 70.9. Right? Let's find out what the second one is. Stat, calc, 1 bar stats, and then we're going to put second L2. Calculate. 210.1, or just 210 is fine. 210. Okay? And then for the third column, we're going to go stat calc, 1 bar stats, and second L3. And the answer is 139. Okay? So the first answer is 70.9. The second answer is 210, and the third answer is 139. And you should also be able to get the third answer by taking 210 minus 70.9. That should also give you 139. If you take the average after 2 weeks minus the average at birth, that should also give you the mean increase. Instead of taking all the increases for each one and taking the average of those, you could do that instead. Okay. Especially if you don't have a calculator. Out of 31 measurements, 15 are below 10 centimeters, 12 are above 11 centimeters. Find the median if the other 4 measurements are blah, blah, blah. Okay, so you got 15 numbers, and you got 10.1, 10.4, 10.7, 10.9. You have 12 numbers here that are above 11. So let's see. We're going to count 15 in from the left and count 15 in from the right because there's 31 total measurements, and that should give us the median. So we counted 15 from the left. From the right, we'll count 12, 13, 14, 15. So here's 15 on the left. Here's 15 on the right. The middle number is 10.1. Okay, we'll mark that as the answer. 11. In an office of 20 people, there are only 4 salary levels paid. Blah, blah, blah. Calculate the median salary, the modal salary, and the mean salary. Well, the modal salary we can just see here, right? Because there's 10 people being paid $28,000, so the modal salary is $28,000. Okay. Now the mean salary, we're going to have to use the calculator. Okay, so we'll do stat, edit, and put it here in L4, here L4. And we're going to use L5 too. Okay, so we're going to put 50,000, 42,000, 35,000, 28,000 in the first column. We're going to put 1, 3, 6, 10 in the second column. Hold on while I do that. Okay, and I took a shortcut here. Instead of putting 50,000, 42,000, etc., I just put 50, 42, 35, and I'm going to remember that these represent thousands and not ones. And so now I'm going to do a stat calc on L4 and L5. Stat calc 1 bar stats on L4 and L5. L4, L5, that's L6. L5, and then I'm going to calculate to get the median and the mean. Median is 31.5. Okay, the median is 31.5. The mean is 33.3. right? X bar is 33.3. So which of these measures of central tendency might be used by a boss who is against a pay rise for the other employees? So he probably wants to make it sound like middle salary, the central typical salary is kind of low, so that it looks like your salary is pretty good. So like if he says that the modal salary is 28,000, then everyone's going to think that they already have a good salary, right? So then the $28,000 people are going to say, hey, or 28,000 euro people are going to say, hey, I have the typical salary, so I don't need to raise my salary. Okay, so that's what I'm going to put. Okay, so I wrote down what summarized that there. Okay, last one. 20b.3, new section. When using information grouped in groups or classes, we use the blank value to represent all the scores in the interval. Therefore, the mean or median calculated for group data is always an estimate. I don't know if you noticed so far, but in the last couple pages, we've only calculated using stat edit, using the column graphs. Okay, and in this case, we want to do the frequency graphs with the intervals. So like, how do you put an interval like 0 through 9 in the calculator? Okay, so what they're saying here is we use the midpoint value. Midpoint value. So for each one of these intervals, I'm just going to put the most typical value for each interval, and that would be the midpoint of each interval. So like the midpoint of 0 and 9 is going to be 4.5. Midpoint of 10 and 19 is 14.5. 20 and 29 would be 24.5, 34.5, and 44.5. Okay? All I did was average 40 and 49, for example. Add them together, divide by 2. And how do I do the calculation now? So now what I'm going to do is I'm going to put two columns in here. Let's use L4 and L5. Clear these out. You clear them out by putting your cursor on the L5 and you press clear. And I'm going to put for the typical values 4.5, because you can't put an interval in here. 4.5, for example. And the next one is going to be 14.5, and so on. And then I put the frequencies, 2, 5, 7, 27, and 9. And then, of course, I do, oh, and which, I forgot, which, I was using L4 and L5, right? So I'm going to do stat, calc, 1-bar stats, L4 and L5. Okay, and then I go to calculate. So the mean is 31.7. 31.7. Okay? You can see that if you had used 0 as a typical value, 10, 20, 30, 40, this would be lower. If you would have used the maximum value, 9, 19, 29, 39, 49, it would be slightly higher. So this is kind of a good central value to use, the midpoint of each interval. And then you say maybe, oh, why can't I just use the exact values? There's two numbers between 0 and 9. Use the exact values. Well, if you had the exact values, you could do that. But if it's in this table, you don't have the exact values anymore. Once you classified these two values together in the class classification in the class 0 through 9, you lost that specific information. Now you need to assume that both of these values is worth 4.5, even though it really isn't. Whenever you get a problem like this, instead of saying the mean, they'll say the estimated mean, or they'll estimate the mean, because you can't really calculate the mean anymore. And that's it.